So it's been a little bit of time since I last updated on this Conquest. I want to show you guys the couple things I fixed to make it drive a lot better, and as well as a bunch of modifications I'm going to be doing in this episode later. A lot of cool stuff. But we took a little hiatus from filming because we've been working on building the cafe up a whole bunch. I'll show you a quick clip of that. What I'm currently working on, which is a new fix really, or a modification. I'm getting this dashboard, the actual factory dashboard, working with the Mega Squirt and the 5.0. The voltmeter works straight up, no problem, as long as you have the dashboard hooked up to your system. And the fuel gauge as well, because that'll go through the factory fuel tank. The oil pressure and coolant you have to modify to get to work. Now the tachometer is actually one of the easier ones, because there's a tachometer output on the Mega Squirt, and you just have to wire the input for the tach, which is actually technically the ground wire. Just wire that ground wire through the Mega Squirt. You have to set it at half RPM for it to be accurate. My oil pressure works. Luckily the 5.0 comes with a oil pressure sending unit right here, and it's wired into the factory harness that I have. It's a single wire unit, and it works the same almost as a tachometer. So power goes through the gauge and gets grounded through this sender unit. All you gotta do is wire the factory wire from this gauge cluster. I'll show you actually which one it is. It's on this big 15 pin, I believe it's 15, blue connector on the back of the dash gauge cluster. There is a yellow with green stripe, and then the big yellow wire next to it. So the yellow with green is for the temperature gauge, and then the yellow wire is for the oil. I have the yellow wire spliced in to that white wire right there, and that white wire I have ran through the firewall into the wiring harness for this oil pressure sender. The only modification I had to do to get that to work was cut the wire about right here, and I spliced in between the wire, of course, in series, a 100 ohm resistor. Exactly 100 ohm, and I got that gauge to sit right in the middle, and it fluctuates. When you give it RPM, it raises the oil pressure, so it's definitely working well. And that coolant sender unit is actually, this is it right here, it's a single wire as well. And this one will also have to be modified. I haven't gotten to that yet, so I'll do that later in this video on which resistance is needed for it to work. You can see right here, I blacked out the speedometer and the boost gauge. Modifying the faceplate of this dashboard right here, the center circle, because I prefer to have a good voltmeter reading. I'm not a really big fan of this one, and the weird thing about it is it's actually wired in parallel with the signal flasher unit, so when you put your blinkers on, this gauge actually bounces up and down, which annoys me. So I'm wiring in this voltmeter. I 3D printed a little circular faceplate so I can set that in there. Similarly, to solve the issue with the speedometer, I'm gonna get something similar to this unit. It's a digital speedometer that is GPS controlled. But I have this in a position right now to where I can show you exactly how I'm getting this set up. I have my voltmeter display, which I have the 3D printed gauge holder for it, and this is just a direct power ground. And my GPS speedometer right here, which the paint came out funky, but I kind of like it. This one is actually a 5-volt supply, which is from a USB plug-in. I took this apart. It originally looked like this. It has that casing on it, but it's actually pretty small on the inside. So to get that 5-volt, instead of getting a voltage divider circuit with some resistors, I went ahead and just used an old cigarette lighter USB charger, which is in here, taped over it just so it doesn't contact anything. I have that being supplied by the same power that this voltage meter will be supplied by. But the grounds will have to go out of this actual casing and to the ground on the wiring harness. What I'm doing is taking the power supply that goes to the boost pressure gauge. The ground on it is grounded through the boost pressure sensor, so we're not using that ground. So both of these reds from this gauge and this gauge wired into this red, and then I poked a hole through right there It's just not part of the actual circuit film on the back. It's just empty. Once it's in, I'll show you plugging it in and wiring it up. All right, while this is drying, a little bit of technicalities here. This being USB powered, this is the GPS speedometer. It came with a cable that was 2-wire, and it originally had a blue wire for the power and a red for ground. I swapped them and I made it just plug in. I didn't want to mess with doing the micro soldering on this, but I have those wires coming out to the USB charger, and then that USB charger output's powered through the same circuit that's being powered for this voltmeter. All right, so what I did here was, instead of connecting the grounds to the actual wiring harness, I put a spade connector, and in here I put a chassis mounted female spade connector. So you can still disconnect it and take the dash out, which is important, but it's not, it will be grounded well. It's all plugged in behind. Oh, my battery's low. The GPS that shows that dashes until it connects to the signal of GPS. And inside of a building like this, it takes a little bit longer, but there we go. 0 miles an hour. My phone mount. Finally, because this car doesn't have any good spot to put your phone at. It sits right here, so I can actually mount my phone, you know, visibly and not blocking anything really. Do a quick video with it at night because it looks super cool. Oh, I didn't mean to do that, but hey. And then with the dash lights on, oh, you can barely see them on the camera, dude. Now, if you watched last episode, you noticed when I was driving it, an ugly, disgusting rattle. We took the exhaust off. This is actually a bigger project because I had to take that off to take the transmission out because I thought my rear seal was leaking. You can take the transmission out without removing the entire drivetrain from this car, which is pretty nice. Toby fixed the rattle in the exhaust, so it sounds a lot better. Plan on getting a actual wideband O2 so I can correctly tune this thing, which I'll be throwing in later. Another thing I did was install a new horn. Last episode you saw me honk the horn. It sounded really stupid and lame. That's because the circuit is fed through the horn button. There's no relay involved at all with the horn really. It doesn't have much amperage that you can be supplying to the horns. So I used that original circuit as a trigger with a new relay circuit. So basically just threw it on a relay to provide full battery power to a new horn. I found out that there's actually a retorquing procedure for the front wheel bearings, almost like a maintenance thing that you have to do on these cars. So it's just the axle nut on the front. You can just take the wheel off with it jacked up. Likely is finger tight if you're getting vibrations. It's super loose, but you tighten it down to 14 foot-pounds, you back it off to finger tight, and then you tighten it down to 4 foot-pounds. And that 4 foot-pounds is all it needs as long as it's lined up with the cotter pin to keep it in place. So after I did that, it actually helped a lot. So there's barely any vibrations at all anymore. The next thing I'll be attempting is the power steering. Now, I know last episode I mentioned it was going to be an electronically driven pump with hydraulic fluid. I was actually about to start doing that with the Toyota MR2 SW20, so the second generation, has an electronic steering pump, which actually is pretty great, but it uses a lot of amperage. And this car already, even with an upgraded alternator, doesn't love a lot of high electrical loads. I found out that the factory 5.0 pump does in fact fit just barely in this spot. I got the original supply line from that pump. Not sure if it's gonna work yet. I might have to modify that. The pressure fed out of the pump is about 1200 psi, and the pressure that the original Conquest pump was putting out was about 1100 psi. So it should be fine. We're gonna put down the power steering attached to this, which is, you know, factory, run the line to there, and then we'll just use the cutoff section. You can't even see it, but I basically just cut the original hose off. We can just clamp a hose to the return because that's not really high pressure at all. It's maybe, what, 20 psi? So clamping it should be fine. So let's go ahead and start throwing this power steering pump in. I took the factory high pressure line from the 5.0 and I took the original flare nut off, and I put the flare nut that goes from this power steering gearbox on the Conquest onto it and double flared it because the one that was on there didn't fit. But Then I took the flare nut from the output and just bandit clamped it to a return line to this. So theoretically this should work as long as the fittings are nice and tight and no leaks are happening. All right, so there's a lot of ifs with this setup, but it's all hooked up, filled with fluid, and I'm really curious if this is gonna actually work out. I hand circulated the pump to get fluid through it, and it's at a good level. I'm gonna jack the front end up just so there's no pressure on the wheels in case even that is too much pressure for the system. I'm gonna turn it on, we're gonna see if it works while it's up in the air. So let's give it a shot. We're looking good. Open. That's huge. Zero leaks. All good. All right, I don't know if you could hear me, but that was a huge success. I'm super happy that worked. I did not think that was gonna work as well as it did. We're gonna see if it actually holds up on the road and on, you know, on really rough asphalt while it's at a sit still. That's where the pressure will really increase, but it's looking great. Clearances are everywhere. Man, that's huge. I could literally turn it with one finger. That just increased the drivability of this thing like crazy because I'm sick of parallel parking, sick of having to pull it out of this spot. Like, it sucked. So the last thing I'm definitely going to be fixing up is the clutch master cylinder. After finding out through a couple drives that the clutch wasn't actually fully engaging, I found out really mostly going highway speeds and giving it gas and it not going anywhere. Not the right size master cylinder. The factory Conquest runs a 5/8 inch bore with about a 1 to 1.1 inch throw on it. And the 5.0, I put the aftermarket hydraulic slave cylinder on it, and that is a 3/4 inch bore. So I calculated out to be a 7/8 inch bore slave or master cylinder. Tilton makes one of those. It's the 75 series, I believe. This is gonna be a little harder to film because a lot of it's underneath the dashboard. First thing I gotta do is get the brake fluid reservoir out of the way. It's just these 2 bolts right here. And then there's a rod coming off. Same setup as this. This rod right here on the right. That goes to the clutch pedal underneath the dash, and that will unthread. Sorry about the wires. That's from the dash. But you see that silver cylinder right there? That is where the rod threads into. So here it is with the cylinder removed. That's the original cylinder. We have a outlet right here on the original, on the side, closer to the driver. And then this new one has an output on the back. This clutch line right here, we can just bend it and it should be able to fit with minor bending, but you might have to use a bending tool to get that turned to be a little bit sharper without kinking it. The mounting holes seem to be close enough. The only issue is on this boot actually causes the diameter to be a little bit wider right here than it is at the base of the cylinder compared to this one. We're either gonna have to shave out a little bit of metal on this right here, make that hole a little bit bigger, which seems pretty tough, or just maybe file down a little bit of the rubber off the outside of this to make it fit. Maybe both. I don't want to end up ruining the seal on this. This piece should work. This is the mounting piece for that. Okay, this will have to be also a little ground out on the inside a little bit more. All right, ground this down a little bit. Now it fits right. One thing I have to do, which I'm going to try, is swap out the push rods from the other one with this one. So you just got to remove that C-clip retainer, and I'm going to see if these rods are similar enough, because this one's shorter and has a different pitch of thread, and it'll just be easier to match it up to the clutch pedals. I think I'm going to be able to put it in like this with the boot off, and then once it's in there I can slide the boot onto it so I don't have to like grind out the metal of that hole or cut this boot at all. So let's see how that goes. All right, I got that swapped over. Looks like it's gonna work perfect. I might try and hook up the clutch line to it before putting this through the firewall. Once this is in, it's gonna be hard to match up that clutch line, so it might be easier just to bend it to go into place. Alright, this is where I'm at so far. Got the cylinder mounted in. Took a little bit of modification. I don't personally like the fact that that line right here loops up, but it'll just be a little bit harder to get the air out of the line. Not impossible. But it's all mounted in and connected to the clutch pedal. So I'm going to put this remote reservoir on. Hopefully I can get it hooked up to the original setup. We'll see how the fitment is, but... I got some good news. I got the master cylinder working just with the modifications I showed you, and the slave cylinder is actually going the entire distance. So I'm certain that that's going to be working. All right, so it's about to snow, but I'm going to take this out for a test run, make sure it's roadworthy, make sure everything's working right, and get it up to operating temperature. And I'm going to make sure that the resistance for the coolant temperature sensor is correct, and that should really be the end of the episode. But I'm... now. See how this does. Oh, that's a quick clutch. Temp starting to rise. All right, we're almost at operating temperature. I'm gonna disconnect the coolant temp sensor and put a variable resistor in line with it. I'm going to do it at a 200 ohm. Turn that dial and it goes from 0 to 200 ohms. Fans on, see, it was in the perfect center. that changes. It's sticking around the center right now. We'll give it about 30 seconds. But it looks like the coolant temp sensor's good. So let's go check the resistance of that potentiometer. 24 ohms. So I'm gonna somehow find a 24 ohm resistor. So I went ahead and used a 22 ohm resistor, and that got it right in the center. It's a red, black, gold stripe combo. All right, that's gonna be it. All right, so that worked out great. Everything in this episode seemed to work out really good. I hope that helped you out. I hope you enjoyed this video. Next episode, I'm gonna be getting a wideband O2 sensor and hooking that up so I can actually tune this because it's running really rich. And I guess later down the line, we'll be doing the body, front bumper and everything. And if you have any recommendations on what I should do next as well, let me know. Thank you.